9-mark differential equations question. This was sent to me by one of the Lund gang on my Reddit page. If you want to submit questions and discuss more maths questions, the link to my Reddit page is in the description. So we're actually going to do 2 today because Christmas holidays and that, I didn't get to record a lot of videos in it. So we're catching up. A tank is shaped as a cuboid with dimensions 10 centimeters by 10 centimeters at the base. Water flows in at a rate of 25 centimeters cubed per second and leaks out at 4h squared centimeters cubed per second, where h is the depth in centimeters after t seconds. Find the time taken for the water to reach a depth of 2 centimeters. Alright, so when you see a lot of yap in a question, most likely you're going to want to draw a picture first, right? So just to see what we're talking about here, we're talking about a cuboid, and we have water coming in, and we have a leak somewhere. Alright, and we have water somewhere inside. Alright. Now the amount of water in the cuboid is h, and they've said it's a 10 by 10 base cuboid. Okay, now with all these questions, you first want to look at what they are giving you. They said that water is flowing in at a rate of 25 centimeters cubed per second and is leaking out by this much. Now this is telling you the rate in which things are flowing. And you look at the units to determine whether it's dV or dA or dx or whatever. Centimeters cubed is a volume per, so a division, time. So it's a change in volume, change in time. So what have they given us? Now this is going to lead into one of my little formulas. I'm going to write informally as what we have got. Okay, now what have they given us? We have got dV by dt. Okay, so we have got dV by dt. All right. So it's an in versus out. In is 25. In is 25. And then what's coming out? 4h squared. Okay, so that's a negative rate. So we're minusing 4h squared. Okay, so they've given us this piece of information. Then we just need to look at the question and say, okay, what do they even want us to find? They want us to find the time, so find t, for the water to reach a depth of 2. So depth is h. They want us to find t when h is 2. So we somehow need to find a formula that links h and t, but we're dealing with rates, right? So what we actually need, what we actually want is dH by dt. That's what we're going to need to solve. So this leads on to my Wagwan formula. What is my Wagwan formula? Is what you want is equal to what you've got times need. All right? So basically chain rule. So what do we want? We want dH dt. What have we got? We've got dV by dt. What are we going to have to multiply this by? Well, this is what we need. We need a dH on top, and we somehow need to cancel out the dV. So somehow we need to find a connection between the volume of water inside the cuboid and the height. And that's very simple because I've drawn this diagram. We can see that the volume of water at any given moment is the base area, which is 10 times 10, which is 100, times the height. So we know that V is 100h. So we can easily work this out now. Here would be dV by dH, which is just 100. Okay? All right, so what are we saying? We're just going to sub things in then. So we got dH by dt is dV by dt, which is this 25 minus 4h squared. Then we're multiplying that by dH dV, which is the reciprocal of this. So I'm actually going to write it over 100. And we can actually simplify that, right? So we get dH by dt. Actually, no, we can't. Nah, I'm bugging. I was going to divide everything by 4, but 4 doesn't even go into 25. Anyway, we need to solve this. Now, this is separation of variables, right? So we're going to bring all the h's over here and all the t's to that side. Now the first thing you should be doing is multiplying through by dt. And you do that because it tells you whether you need to include brackets or not. Okay, now when you multiply through by dt, it's like this. Now this does not look good because there's two terms here. You need a bracket to protect that. So to get this on this side, we're going to have to divide. Okay, so we're going to have to divide by this. And at the same time, I'm actually going to multiply through by the 100 because most likely that's just going to help with constants. So I'm going to multiply by 100 and I'm going to divide by this. And when I divide by this, I'm going to integrate, right? I already know I'm going to have to do partial fractions, so I'm going to factorize this as well. So 25 is 5 and 5. 4 is 2 and 2. 1 is plus, 1 is minus. dh is just 1 dt. Integrate both sides. Okay? So, let's just do the partial fractions. I'm just going to clear the board over here because I don't think we need it anymore. Right, we have this, and we're going to do partial fractions. We're going to split this up. All right, so we're going to have a over 5 plus 2h and b over 5 minus 2h. Okay, now I'm going to show you guys a trick to finding a and b super quick. What you do, to find a, I'm going to show you guys the cover-up method. You just say, what value of h makes this denominator 0? When you make that equal 0, you get minus 5 over 2. Yeah? So h is minus 5 over 2. And what you do is you cover up the minus 5 over 2, and you're going to sub in minus 5 over 2 into here. So you're going to get 100 over 5 minus 2 times minus 5 over 2. Now write this down, don't just do everything in the calculator, because you want to show the examiner a little bit of what you're doing. The 2's cancel here, the double minus is plus, so you get 5 plus 5, 10, 100 over 10 is just 10. Okay? Doing the same thing with this one, when you make the denominator 0, you're going to get 5 over 2. Alright? Now this time you cover up these same denominators, so we're going to get 100 over 5 plus 2 lots of 5 over 2. The 2's cancel, 5 plus 5, 10, so we get 10 again. So, going back to this, we are integrating. Now, both of these numerators are 10. I'm going to do something cheeky here and factorize out the 10. You don't have to do this if you don't want to. It's just standard practice that I do with all my students in my classes. If you're interested in that, you can go to the description. There's a link. So, here we have 10 over this, but I factorize out the 10, so it's 1 over 5 plus 2h. Then we get plus 1 over 5 minus 2h dh is the integral of 1 dt. Now, I don't have limits here, so I'm just going to integrate that now. Actually, I'll do it later. Integral of t. Whoops. That's what 1 integrates to. Integral of 1 dt. Now, how do we integrate these? I'm going to make a guess. It's just reverse chain rule. It's a fraction, so ln of the denominator. When you differentiate that, you get over this. Differentiate this gives you 2. All right? But we want 1, so I'm going to half both sides. And it's going to be the same case here, but it's going to bring out a negative. So I get ln 5 minus 2h. I get over 5 minus 2h. Differentiate that, I get minus 2. So I times by minus a half because we want plus 1. So times by minus a half. So I have 10 lots of a half ln. Now you should be thinking about the constant of integration, right? I always put the constant of integration within one of the lns. Okay? So I'm going to put in the first one. Instead of writing plus c, I'm going to write a lots of 5 plus 2h. So there's my constant of integration. Because you can break it out, you'll get ln a plus ln of the other thing. Ln a is just a constant, so it's the same thing. Then we get minus a half ln 5 minus 2h, close that bracket, is the integral of 1, which is just t. Okay, what I'm going to do next is I'm going to factorize out the 2's, which makes this 5. And then these luns with the minus is going to become division. So I'm going to get lun. So 5 lun of a lots of 5 plus 2h over 5 minus 2h. Okay, that's looking pretty, and that is t. And then I'm just going to rub out that side. Right, the next thing I'm going to do here is I'm going to divide by 5 to make it 1/5. And then I'm going to e to the power of both sides. Just to be informal here, imagine I'm dividing by 5. So we get t over 5. Then I'm going to e to the power of both sides. That looks awful to get that. So I'm going to get a lots of 5 plus 2h over 5 minus 2h is e to the 1/5 t. Now the next thing I'm going to do is I'm going to find the constant of integration. Now I've rubbed out the question, but if Hockey is feeling nice, he's going to put the question up there again. It says that the tank was initially empty, meaning when t is 0, h is 0. So when you sub in h is 0, that goes, you get 5 over 5, which is 1. We're literally going to get a is e to the power of 0, which is 1. Okay? So there we go. We get a beautiful equation. 5 plus 2h over 5 minus 2h is e to the 1/5 t. And then the question said, find the value of t. Oh, maybe I didn't even need to rearrange this. It said find the value of t when h was 2, wasn't it? So when h is 2, 2 times 2, 4 plus 5, 9 over 2 times 2, 4, 5, 1 is e to the 1/5 t. I don't know if it wanted exact or not. So we're going to ln both sides. I get ln 9 is 1/5 t. Then times by 5. Now I actually don't really like this answer because 9 is a square number. I'm going to change it slightly. I'm going to write 9 is 3 squared. In the real exam, I'm not sure where this student got the question from. It's a really good question, by the way. But most likely they were in the form of ln k, where k is a prime number or something. So we bring down the 2. My final answer is t is 10 ln 3. And that is a beautiful question, Mike. Let's move on to the second one. This Easter, me and my teachers are hosting revision courses for maths, further maths, chemistry, biology, physics, and English GCSE for super cheap. If you're interested, link in my bio. Question 2 in that. There was a lot of yap again. I've actually just tried to summarize, but the picture of the question from Reddit will probably show up somewhere. So if you are wanting to submit questions, go to the Lung Gang Reddit. Link is in the description. So it says the diagram shows a water tank shaped as an inverted cone with semi-vertical angle 30 degrees, height 50. Initially the tank is full and the depth of water is 50. Water flows out of a small hole at the bottom of the tank. The rate at which water flows out is minus 2h, where V is the volume of water in centimeters cubed, and h centimeters is the depth of water in the tank t seconds after the water begins flowing out. Determine the time taken for the tank to become empty. So it's very similar to the question before, but most likely this one's not as hard as the one before. Okay, so the first thing we do is we focus on what they've given us. What we've got is dv by dt, which is minus 2h. Now what do they want? Determine the time, so they want t when what? To become empty. Empty means h is 0. Alright? So, let's think about our Wagwan formula. So, want is got times need. We want dv dt. What have we got? They want, well, sorry. No, wait, what am I on about? I don't want that. That's what we've got. We want a relationship between h and t. So it's like before, we want dh dt. They all follow a very common theme. We have got dv by dt. So we need dH by dV. So we somehow need to find a relationship between the volume of liquid inside this cone and the height. Now we know that the volume, now sometimes they give it to you, I can't remember if the question that was given to me did, but you guys should remember this anyway, is that a volume of a cone is 1/3 base area, because it's a circle, is pi r squared times the height. Now the problem here is this radius, all right? We somehow need to find the radius of the liquid that is already, well, that is basically in the cone, all right? Now to do that, we're going to form a right-angled triangle. Now that's a right angle. And this is R, your radius, and this is H. And the way we're going to do, we have to basically rewrite that R in terms of H. And the way we're going to do that is using, I guess, similar... Oh, no, wait, no. You can just find a connection because you have the angle, right? I was going to say similar triangles, but we don't have the radius of the actual cone. So opposite, adjacent, tan. So we're going to say tan 30 is the ops over H. The ops is R over H. So it's R is H tan 30, and tan 30 is 1 over root 3 or root 3 over 3. But actually we're going to square it, so I'm going to write 1 over root 3. 1 over root 3 H. So the volume then is 1/3 pi times R squared. When you square that, you get 1/3 H squared times H, which is 1/9 pi H cubed. So now we do dV by dH. Bring down the 3, 1/3 pi H squared. So we have dH dt is dV dt, which is minus 2H, times 1/3 pi H squared. Now this is actually a much easier thing to solve than the previous question. So I have dH dt is minus 2/3 pi H cubed. So what I'm going to do, guys, I'm just going to clear this and carry on with the working, mate. DH. Oh, no. Oh, damn. I didn't reciprocate it. So that should have been 1 over. Okay. I'm going to have to backtrack. So backing up, I need to reciprocate this. So I'm actually going to write this as pi H squared over 3. So I'm going to do 3 over pi H squared. So we get dH by dt is oh, that cancels. So I get minus 6 over pi H, which is actually even nicer than the one before I had. Times through by H. So I'm going to get H dH is times through by dt minus 6 over pi dt. Integrate both sides. H just becomes a half H squared. Wait, yeah. Man, I'm bugging out right now. That first question did my head in. So we times through by that. Yeah. Now this is just a number, right? It's like integrating minus 6. Minus 6 would become minus 6t. So this just becomes minus 6 over pi t. Then here we have to write plus c. All right. I think now let's just work out what plus c is. Now, I have rubbed it out. It did say that initially this thing was full. Initially meaning when t is 0, it's what we want h, right? Initially, h is 50. Okay, so we sub in here. H squared is 25, where's my thing? 2500, right? 50 squared, whoops, 50 squared. Then divide that by 2. 1250 is this. Oh no, but t is 0, so just c. All right. Find the value of t when h is 0. So when h is 0, that just goes. We get minus 6 over pi t plus that 1,250 is 0. So you move that over. So we get 6 over pi t is 1,250. And then we just divide. So I'm just going to do an approximate. 1,250 times pi divided by 6. I get about 654. I don't remember what t was in. Maybe like seconds or something. I won't fill that in. I think it's going to be in seconds though. So that is that question for 7 marks. So guys, you can make mistakes. Obviously, I've proven to you guys that it's easy. You know, if you're not focusing and you're just in your flow state, you know, you can make simple mistakes. But that is that. So guys, if you want to submit questions for the Lung Gang to help you out, and maybe I'll make a YouTube video on it, head to the description, go to my Reddit page. And if you're interested in my A-level courses to prepare you for your final exams, then there is a link to my courses in the description. By the way, subscribe for more videos like this, and like if you learn something nice.